welcome to LeetCoder YouTube channel. If you are new to this channel, I'll highly recommend you to subscribe to my channel as I make content related to software engineering, system design, and data structures and algorithms.
Okay, so hello everyone, welcome to LeetCoder YouTube channel. So today we are going to solve LeetCode problem number 208, implement trie, which are also called prefix tree. So we'll be going through the problem statement quickly, and after that I'll try to explain a bit more about trie. We'll try to code this problem together, and in the end we'll try to write some time complexities and space complexity which trie data structure take. So let's get started. So what this problem expects from us is they want us to implement a trie. Okay, so a trie or prefix tree is a tree based data structure used efficiently store and retrieve keys in a data set of strings. So as we know, when we have a lot of strings and we want to check whether this string is a part of this dictionary or not, we want to do a lot of prefix based searches. So trie is a really good data structure for such kind of problems. So he's just talking about the applications like autocomplete is a kind of application and spell checker is a kind of application. So these are classic applications of trie data structure. So here what he wants us is he wants from us is to implement the trie class. He has given a trie class, and he is expecting us to we will complete these methods and constructors and everything. So there is a trie, there is constructor, then there is an insert method. What this method does is this method inserts the string word into the trie. And then we have a search method. What search does is it returns true if the string is in the trie, otherwise it returns false. Okay, search is pretty straightforward. And then we have a starts with also. So starts with is nothing but if there is any word which contains this prefix, in that case we need to return true and otherwise false. So starts with this, just that. So now this is the problem statement, and he has given a good example to understand all the APIs and constructors and all how they work. So trie he has initialized, then insert, when he does insert apple, the apple got inserted into the trie, then he searched apple. Okay, and it should return true. Fine. Then he searched app. Okay, then it should be false because app is not in the trie. Then he searched, then he did starts with. Okay, app is a prefix in apple, right? So it should return true. So that's what is happening. And after that he inserted app as well and then searched, and it is returning true. So he has demonstrated a test case for our reference. So this is the problem statement, and there are some constraints given. So let's go through the constraints as well one by one. So the length of a word is going to be between 1 to 2000. Okay, and word and prefix consist of only lowercase English letters, and at most these number of API calls will be made. So as such these constraints are given, and we can go through them for like more understanding of the data which is he is going to put in our methods. So let's move to our whiteboard and try to visualize this problem better. So okay, so what he wants is like let's say we have some strings, right? Let's say we have an array of strings, right? Like this. Okay, there is apple, app, and then apple, and then maybe add, and then banana, right? And so on. Okay, so we need to efficiently create a tree for these kinds of strings. So how we can create a tree? We are going to have a node. Okay, so this will be our node, it will have a boolean parameter end of word. Okay, so whether this node is an actual end of word or not, I am going to use that this end of word for that parameter. If it is true, it means a word ends from here. If it's false, it means no word is ending, and this is a intermediate character of a word. So next we are going to have is a kind of array. Okay, array of size 26. Now what this array is going to contain is reference to these nodes only. Okay, so this is a node. It will contain the references to the other nodes, similar to a binary search tree or binary tree. Okay, so let's try to convert this array into a data structure like trie. So what will happen is the end of word will be false. Okay, and the first node will be a, and then it will link to a node which is p, and then end of word will again be false, and then it will link to another word p, then end of word will be false here as well, then it will link to l node. Okay, end of word will be false, and then it will link to e. Here the end of word will be true. Okay, so this is a tree for the word apple. Okay, so this word we have covered, this word we have covered, apple. Now for app, what we can do is a, which will be starting from here, a p p. Okay, so here we can mark end of word as true because we have a word in our corpus app. Okay, so this we can simply make it true. Then we have add. So what we are going to do is d will be somewhere here. Okay, d, then end of word is false, and then again d, for which end of word is going to be true. So this is the kind of add word in the trie data structure. So far we have represented these three words, and the last word would be banana. So what will happen is b will be somewhere here, and then b, and then a, and then n, and then a, and then n, and then a. Something like this. For this end of word is going to be true. For all of the others, end of word is going to be false. Okay, end of word is false. Okay, end of word is false, end of word is false, and so on and so forth. Okay, the word is false. So this is our trie for this dictionary, assuming we have really large number of words. So we'll have a very tree like trie for that corpus or that dictionary. So next let's try to visualize what kind of operations he'll be doing on this trie. Okay, so insert is trivial. I inserted already these words in a trie based data structure. So insert, I think you can visualize pretty much from this example. So the next API which he wants or he is expecting from us is the like search method. Like he'll give us a word and we need to check whether that word is present in this trie data structure or not. So how we are going to proceed for that is we are just going to iterate this trie iteratively from top to down. We already have this route, right? So we'll start from here and we'll try to iterate this tree. If we reach a word for which end of the word is, let's say, true, then it's surely a valid word in our dictionary and we are going to return true. In all other cases, we are going to return false because that word is not present in our dictionary or in our trie data structure. So that's what he's expecting with the word with the API search. Now the next API he has is starts with, right? So starts with, he just wants to like ask whether that prefix any word with that prefix is present in our try or not. So it's also very easy. Here you just need to iterate this try, and you shouldn't be concerned about end of the word. Like it just need to iterate on this try. If it's iterating fine, there are nodes at the corresponding characters, then we are good. Otherwise we can just return false. So that's what our the starts with API. So we have already talked about the insert. Okay, we have already talked about search, and we have already talked about starts with. Okay, starts with. So next let's try to code this, but before coding, let's talk about the time complexity here only. So assuming like there are n words, sorry, assuming there are n words, and the length of each word is capital M. On an average, this is length of each word. Okay, so what is going to happen is or what is going to be the time complexity of each of this operation. Okay, insert, let's make a table kind of. Okay, so let's say this is the search API, and this is insert, and this is starts with. Okay, so let's write the time complexity here and space complexity here. What are the values for them? So let's start with insert. So I want to insert m words in the try, right? For sorry, I want to insert n words, and on an average the length of each is m. So the time complexity is roughly O of n into m, right? In the worst case, let's say all are different nodes, and yeah, this would be the worst case one. Similarly, the search, let's say I am doing the search for n strings and each is m characters. So again, search is also going to be n into m, and starts with also n into m, right? And similarly, space complexity is also O of n into m, right? Let's say all the words are different and there is no prefix forming. So again, this figure is going to come similar to n cross m. So this is the time and space complexity of all the APIs. So now let's try to code our approach. Okay, let me fit this. Okay, so let's move to the okay, let's start coding. So let me make a root variable. Okay, and then I'm going to make a class node. Okay, this node class is going to have an array of nodes, which I'm going to call array, and boolean parameter end of word. Okay, then I'm going to have a constructor node and my end of word is going to be false by default. Okay, I'm going to have some getters and setters as well. So node get ARR. Okay, so it is going to return this array, and similarly I'm going to have two variables, set end of word, and here I'll pass the parameter boolean end of word. I'm going to do this dot end of word is end of word. Okay, similarly I'm going to have a getter for this boolean get end of word, and I'm going to return my end of word here. Okay, so next let's try to write the constructor. So constructor is simple, just write this thing. This is the root node which we want to initialize. Let's try to write the logic for insert. Search and starts with, let's start with the insert one. So node head equals to root, and let me iterate for the entire string. Okay, so sky value of the word and after that I'm going to get a node array. Temp is get ARR. Okay, what I'm going to do after this, if temp of sky is double equal to null. Okay, so I'm going to explain you this condition, why I'm doing if. So you need to think like why if is required here. Actually, when you are searching and if the search succeeds, like we are able to find the node of character after character, but if you don't keep this check now, you will lose some of the words. You will be making a new node at that place, and there was already a node existing at that place, and you lost that data or that information. So what you should do instead is you should keep that information, and on top of that add your information. So that's what this if is doing. So the next part is head is equals to temp of ASCII, and I am going to do head dot set. I'm going to call that setter, set end of word, and pass on the true parameter. Okay, the next part is search, and then after that we have starts with. Okay, so let's go to search now. Node head is root. Okay, for int I is 0, I is less than word dot length I plus plus. ASCII is equals to word dot caret position I minus sky value of a. After that node temp is equals to head dot get ARR. Okay, and similarly I'm doing that check if temp of ASCII is double equal to null. I'm going to return false because no word exists, right? Otherwise I'm going to continue my iteration. Temp of ASCII. Okay, and in the last I'm going to return true. So now let's move to the starts with function. Starts with function is very similar to search. Actually I'm going to copy this code and paste here, and for a moment let me replace the prefix with the string word so that we don't have that kind of errors. So what we are going to do here is wait a second. So here actually for search we need to check whether it's end of word or not. So here it will be getter for is end of word, get end of word. Okay, this will come here. Yeah, for this we are pretty sure. So that's the code for all the APIs. I think this should work. Let me try to run this code once if we are doing something wrong. Line number 30. Task key. Word. Okay, typo. Let me run this again. Word. Let me run this again. 56. Word. Okay. Let me run this again. Yeah, it's getting accepted in the sample. Let me submit it. Yeah, it's getting accepted. So that's all I wanted to talk about this problem. If you liked the approach and the explanation, do subscribe to my channel and do give this video a thumbs up. It really motivates me to make this kind of live videos. So once again, thanks for watching this video. Bye bye.
Hey guys, do check out this Instagram channel, LeetCoder Community, for all the jokes and memes